Hello friends, welcome to Many Advantage YouTube channel, and this video is about introduction to MPLS and Mpls VPN. This is good for CCNP students as well as who are studying for CCIE. So this will be my main goal is to give you guys the fundamental view of Cisco IOS Mpls VPN. So let's try to understand this diagram before we divide into the configuration stuff. So in this diagram, I have CE1 router and CE2 router. So CE routers are called customer edge router. Then my MPLS cloud consists of 4 routers. One is PE1, other one is PE2, other one is P1 and P2. PE1 and PE2, they are referred as provider edge router, and P1, P2 as provider router. So you can consider this MPLS cloud is can be as an ISP. So ISP, and also the beauty is like in the ISP environment, you don't have to run BGP inside the core devices. So for that reason, I'm not running BGP either on P1 or P2. But what I did, so all the 4 routers are part of OSPF area 0. So in the industry, sometimes the ISPs, they can use ISIS as a protocol or they can use OSPF as a protocol. The main advantage of both ISIS and OSPF, they are the only true link state protocols right now. So most of the ISPs, they use either OSPF or ISIS. So in this one, I already configured OSPF just to make configuration faster. And I have configured the loopback zeros in /32-bit, as you see here, 3345555666. And also I'm running OSPF here. So OSPF is pre-configured with the IP address. So that means if I go to R3 and type show IP route OSPF, I should see 4, 5, 6, and these two link as OSPF. And unlike, so when I want to configure MPLS, that's what I'm going to do first. So first we will configure the cloud. We will verify the cloud. Then after that, we will use the service. So one of the main services is Mpls VPN. So when we do Mpls VPN, I'm going to configure a virtual router called Many ADV. And also at that time, we will go through the topics of what's the meaning of RD, RT export, and RT import. Normally in my classes, I explain in detail, but today our focus is do the lab. So guys, without any delay, let's go to the labs. So I have routers. So let's go up again, guys. If you want to look my channels, you can subscribe to my Many's video. So on YouTube or Google, you can type Many Advantage to look at my channel and my other videos. So guys, right now so let's go to the lab. I want to show you, I have all the connectivity right now on all the routers. Okay. So what I'm going to show you right now. So I'll go to CE1. As per the diagram, I'll go to enable. If I type 12.12.12.23, I'm going to try to telnet to router 3. So I'm on router 3. From here, if I telnet to 150.50.34.4, I should go to P1 router. I'm on P1 router. If I go to 150.50.45.5, I should go to router 5. Same way, if I go to 150.50.56.6, I should go to PE2. And from PE2, if I telnet 26.26.26.2, 26.26.26.2, I should be going to the last CE router. So right now, if I type show IP protocols, I'm not running any dynamic routing protocol on CE2. So let's see that one later. But if I type, so you might wonder what I did. So if you don't know, if I type show run begin line. So in order to telnet like this, what I did, I type line VTY 0 to 4, then I type privilege level 15, then I type no login. So basically I'm saying there is no login required. Anybody telnet to the line, just allow to privilege level 15. By typing the IP address, that means Cisco IOS know that I'm trying to telnet to the router. So I'll go all the way back to my CE1 router. So that's my original router. So guys, in order for this to work, as I said, we want to enable MPLS. So enabling MPLS has a couple of commands. So PE1 router and PE2 router, the customer facing interfaces will not be part of MPLS, only this one. So you have to be very, very careful in this one. So I'll go to PE1 router. So I'm going to write a template. Then I'm going to apply the template to all my configurations. So just to make everybody aware of, the template is very good. So now we are going to target to configure MPLS. So very first command, what we need on the Cisco IOS is you need IPsec. Then you need, so let's type that one, config t IPsec. Then I'm going to type command mpls ldp router id loopback 0. It's best to force, otherwise initially you can type without forcing, but even if you force is okay. So I'm going to just build the template as we type. So that's the second command required. Then third command, the best thing is mpls ldp. There's a command called mpls label protocol. So I can type anything in Cisco, but I prefer LDP. So I don't want to leave it for the default. I want to hard code everything. So again, that's a global configuration command. That's it, guys. Then what I had to do, there are two ways to do. So this one, then I had to go to the relevant interfaces and type mpls IP. Or on one of the router, I'm going to show you another method. Under the routing protocol, you can say mpls ldp autoconfig. This is a very powerful tool. Again, CCNP level, I don't think you have to know, but it's best to know. So there are two ways of enabling MPLS. This one or this one. So I'm going to do, so what I'm going to do on router 5, I'll use that special command, and router 3, 4, 6 we will enable properly. So but we have to know, we have to type this command on all the routers. So that's given. So I'm going to copy this one and type on all the four. Even better, I can type enable config t, then I can type end, write mem, enter. So basically what I'm trying to do is I'm going to configure the mpls later command. Lots of people, they do mistakes of not doing properly. So on R3, what I will do, I will just copy and paste. So basically the commands are being done on R3. I will go to now P1, enter. So the commands are taken. I'll go to P2, enter, done. Then I'll go to P2, then enter. Okay, so initial commands are done. On PE1, what I had to do now, I had to go to interface Ethernet. I had to go to config t interface Ethernet 01, and I had to enable MPLS. To enable MPLS, command is MPLS IP. So I'm enabling MPLS. On R4, I'm going to have to do on two interfaces. I will type interface Ethernet 01 MPLS IP, then interface Ethernet 00 MPLS IP, exit. Then I will go to router 5 and I'm going to put a special command. So I want to see what OSPF I'm running. So if I say show run section OSPF, I'm running OSPF 1. So router OSPF 1 MPLS LDP autoconfig. I can just enter or I can type area, so it doesn't matter. So I'm going to just type enter. Basically what this is going to do, whatever interface enabled for OSPF will be enabled for LDP also. So remember, MPLS need label protocol. So it is based on label. It is label 2. Is a layer 2.5 protocol. So labels can be either TDP or LDP. TDP is Cisco proprietary tag distribution protocol. On the other hand, LDP is label distribution protocol. So let's go to R6. R6 has one interface. So config t interface Ethernet 01. I'm looking at the diagram. You have to always print the diagram or like draw the diagram and keep it. MPLS IP. So guys, that's it. So we have done the MPLS cloud. If everything is good, if I go to this R4 router, if I type show MPLS interfaces, so you can say what interfaces are enabled, show MPLS LDP neighbor. So you're going to see two neighbors. But the very important command, what I tried is show MPLS LDP discovery in Cisco iOS. This is what most of the people use in a high-level studies. And you must see the neighbors with XMIT and receive. If you see XMIT and receive, that means you have a proper LDP neighbor relationship. If you find something wrong, no route, something, that means you're not doing good. So I would like to test this one on R1 and I would like to test this on R5. So what I will do, show MPLS LDP discovery. And also guys, I want to, because we are doing basic MPLS, I want to show you around four tables. I will go back to my whiteboard here. So this whiteboard we are going to keep on add. So there are 4 tables. One is called RIB, so routing information base. Then there's something called lib, label information base. Then there's something called fib, then lfib. So the action wise, if you want to see, I'm going to type show IP route. If I want to see this one, I'm going to say show MPLS LDP bindings. So it's going to show me all the labels. If I want to see fib table, that's why the Ceph coming into play, show IP Ceph. And also if I wanted to see lfib, the command is show MPLS forwarding table. So guys, if you're going to do any theory, CCIE, CCNP theory, I think these are very important. So remember, these two tables are in the control plane, so that means control plane, and these two tables are in the data plane. So data plane is used to route the data. So let's go and see all this table on PE1 or router 3. Okay, so show IP route. I know I'm running OSPF, so you're going to see OSPF route and see all the loopbacks are coming as a 32-bit route. It is advisable to use 32-bit route loopbacks. Then show MPLS LDP bindings. So you are going to see all the labels assigned. Most of the time labels are going to be more than 16 value. Again, this is not a MPLS course, so I'm not going to talk about implicit null and explicit null. By default, the labels are implicit null. That means it is going to do something called PHP behavior, penultimate hop hopping. So again guys, that's beyond the we will talk about in a different time frame. So I won't take the fib table. The command is show IP Ceph. So show IP Ceph will display fib table. Just say in the fib table, I'm not saying what routing source, but it's an orderly mannered table. So very important thing is show MPLS forwarding table. So basically this is called action table, sometimes called lfib table. In an order, routing information base, label information base, forwarding information base, label forwarding information base. So if I type this one, just see you're saying to go to 444, I'm going to pop the label because router 3 will say 444 is directly connected to my attached router. So wherever you say pop label, that means that networks are directly connected to attached router. But other one, I'm going to do swapping. Local label, when I send, I'm going to say label number 17. You're going to say, and right now there is nothing going through. So I'm going to show you MPLS in action right now. So let's go to one of the middle router and type show MPLS forwarding table. I see something. Let's go to router 1 and we'll enable MPLS to do the checking. I'm going to do ping router 6 loopback 0, 6.6.6.6, source loopback 0. I can say repeat. Maybe let's give around 3000. It's going to be fast. Ping not from router 1 guys, I should be doing. So I'm going to stop this one, Control Shift 6. I want to do this ping from PE1 because router 1 don't know anything. So I should be doing the same command from PE1. So I'll copy this one, go to PE1 and enable. It should work. Let's go to quickly. Oops. Okay, we have to give higher number, maybe 30,000. 3,000 is not good. I'm going to give 30,000. I'll go to P1, do up arrow. Just say the number of packet label switches getting increasing. So basically this is one of the way you can prove that MPLS is in action. So right now I know the MPLS is working. So that means the routing between 333 and 666. So what, unlike other vendor protocol, for example Juniper, Cisco by default, when you enable MPLS, whenever you do normal IP routing between in Cisco by default, the router will generate a label for every route in the routing table, or sometimes called FEC. FEC stands for forwarding equivalency class. So guys, right now our network is ready for this. This is kind of a cloud is ready. My next task is to allow the customer in router 1, customer 1 in one location to talk to customer 2 in one location. Maybe this is on the East Coast and this is on the West Coast. So we are going to use MPLS cloud. So normally when it comes to, so most of the actions are on PE devices, because P1 devices are kind of doing label swapping, is going to go through label swapping technology. So again guys, if you like the video, you can subscribe to my videos, many advantage. Let's go back here guys. So here what I'm doing, CEPE routing protocol, I'm going to use OSPF. In this side, CEPE routing protocol, I'm going to use BGP. So my cloud my core network is using AS number 12345. Guys, remember these AS numbers and the IPs are demonstration purpose only. It is not to be considered as a like these IPs might be belong to different purposes, but we are just using only solely for the purpose of education only. Okay, so BGP AS number 12345, BGP AS and number 222. So I had to create a special BGP between PE1 and PE2 and carry this customer traffic. So I'm going to create that one. But before that, I want to show you this one too. So what we have to do, so maybe this customer is called, I'm going to create a virtual routing forwarding called many ADV. And there's a concept of route distinguisher. So route distinguisher purpose is it uniquely identify a route within the MPLS cloud. Then I'm saying most of the time the route target import export is same number 100, 100, 100, 100, 100, 100. But it can be different. So for the purpose of demonstration, for mainly for CCI candidates, I'm using a different number. So I'm going to export something. I'm going to put 200, 200. On this side, I'm going to import that 200, 200. In this side, I'm going to export 400, 400, and I'm going to import 400, 400. So let's see how to do this one. So let's do two things, guys. First, I'm going to enable this guy. So let's go to the router. Even better, we can go to our template. So in the template wise, what I'm going to do, I'm going to say IP VRF many ADV. Then I'm going to say RD 100:100. Then I'm going to say route target export 200:200. Then I'm going to say route target import 400:400 on the other. So this is going to be on the PE1. PE2, I'm going to reverse this one. Okay, so let's see what to do right now. Okay, so let's enable this one on PE2. So this is kind of configuring. I'm on. So this is one of the very important commands, guys. So on the PE1, enable config T. That's it. So I enable a verb called many ADV RD. So what is the difference between RD and RT? So technically speaking, route distinguisher is a 64-bit value. It is prepended to 32-bit IPv4 to get something called VPN v4 route. That VPN v4 route is 96-bit. The main advantage of route distinguisher is nothing but to make a customer route unique within MPLS cloud. Now when it comes to route target, they are BGP extended community attribute. They are not normal BGP community extended. It is mainly used to take route from IPv4 BGP to VPN v4 BGP, that is export. The import means take route from VPN v4 back to IPv4. So that means we have to do route target export import between address family IPv4 and address family VPN v4. Let's do the lab, guys. But right now what I have to do, this Ethernet 00 is part of this one. Just do this one, guys. Do show run interface Ethernet 00. If I type interface Ethernet 00, now I have to say this interface is part of that many ADV. So the command is IP VRF forwarding many ADV. So just see, as soon as I type, the IP address is gone. So I have to retype the IP address. That's for the security purpose. I'm going to retype. If I type show run interface Ethernet 0/0, you will see IPVRF forwarding. So that means now if I want to ping other guy, if I do ping 12.12.12.1, it won't work. But I must type ping VRF many ADV. I would say 12.12.12.1. It's working. And also if I type show IP verb, it tells me I have a verb called many ADV, then default RD, then it's I'm saying so mainly for CCIE candidates is very important. For troubleshooting, you have to see what interface are. Sometimes people enable MPLS IP on the customer facing. That's wrong. Sometimes people put IPVRF forwarding on the core facing. So remember, PE1 has one leg for the ISP side and one leg for the customer. So customer facing interfaces, you must put IPVRF forwarding. So you see all the commands here. All the commands here. So let's go back to here. So this is very important. And also if I type show IP route VRF many ADV, I'm seeing that 12.12.12 as a connector route. But if I type show IP route, the 12.12 is not there anymore. 1212 is gone because it is part of a verb. So that means this router right now has two routing tables. One is a global routing table and also a verb routing table. So let's do the same exercises for other PE. So as we know, we have to change some parameters. We will do the parameters because that's by design. We decided to do that one. So I'm going to put this side as 400 400, and this side I'm going to use 200 200. That means whatever other side export I want to import. So if you use the same number, you don't have this trouble at all whatsoever. Okay, let's enable that one. Then let's look at the diagram. That one also Ethernet 00. So I had to go to do show run interface Ethernet 00. I want to get the IP address. Then exit interface Ethernet 0/0 IP VRF forwarding. If I put many advantage, is going to fail because there is no verb I created. So I had to put many ADV. Okay, then I had typed the IP address like before. Okay guys, so we have done that part. Now I want to show you how to enable VPN v4 peering between PE1 and PE2. So it's a BGP with the AS number 12345. I want to establish between my loopback 3333 and 6666. Let's do that one. I'll go to my whiteboard here. So I have a sample template. I'm going to modify the sample template so it will be easy. So my VPN v4 peering, my BGP AS number is 12345. Let's see, I'm doing on R3, sorry, PE1. So PE1 loopback is 333. So neighbor is going to be 6.6.6.6. That's the reason we are enabling. So that means to go to 666 is going to use label swapping. So updating from source loopback 0. So then I had to go to, so it's always best to say no BGP default IPv for unicast. What you are doing, you are telling I don't want normal IPv4 BGP, but I need to have a VPN v4 BGP. So you guys know what is VPN v4. It is 32-bit IP address prepended by 64-bit route distinguisher, and it is attached with route target attribute. It's a BGP extended community attribute. So guys, let's do this one. So you can always pause the video and you can just get a glimpse of what I'm doing. Very interesting topic, and if you know this one, very easy to get a job in ISP environment. Okay guys, so PE1. So let's go to PE1, enable config T. I'm going to just copy and paste. That's right. So now go to PE2. So if I go to PE2, PE1 loopback is 3.3.3.3. So you have to make sure your MPLS is good. So and now I'm establishing the routing, and we should see the VPN v4 BGP up, and it is not sending or receiving any routes. So once we do everything, let's go through the commands just to make sure everything is good. So I'm going to copy this one to my PE2 router. So I'll go to my PE2 router. So I'm going to just copy and paste. So guys, what I did right now, I'm enabling VPN v4 peering. It should be up. Let's see. Show BGP. So there are two ways to do show IP, BGP, VPN, v4 star summary, otherwise all summary. It is idle, so we have to wait. It should be establishing a BGP neighbor. First of all, I'm going to ping and see ping 3.3.3.3 source loopback 0. I'm pinging, so it should come up. Let's check the configuration one more time. Show run section BGP. Okay, I know the problem because copy and paste. It's not 111, so I'm going to fix it right away. So guys, I like to do the mistake and do it, so that way you will learn it. Okay, So so I'm going to type no neighbor 3.3.3.3. Remote A is 111. Neighbor 3.3.3.3. Remote A is 1, 2, 3, 4, 5. That's missing. Okay. Then update source loopback 0. Address family VPN V4. Then I'll type these commands together. So I know, like, so let's check again. Show run section BGP. Looks good now. So let's go to PE1 and do the same, correct the same mistake. No neighbor. So always never. Okay, so now neighbor 6.6.6.6. Remote A is 1, 2, 3, 4, 5. Update source loopback 0. Then address family VPN V4. I'm going to put this command separately. Activate so you need the send community either extended or both. This is to send the route target community attribute. Let's check the configuration, guys. Do show run section BGP. So if I type do show run section BGP is showing me the VPN V4. I did not create this one, it's automatically coming. So let's check the neighbor right now. Show IP BGP VPN V4 all summary. It's telling me the VPN V4 BGP neighbor is up, but I'm not receiving any routes or sending any routes. So that's good sign. So we have the path right now, and instead of summary, if I type all, I'm going to see the routing table, but right now there is nothing to display. So guys, we are doing a very good progress. So now, so R1 and R2 is normal. So let's configure those two first. They are very normal routing. You don't have to have MPLS experience at all. So what I'm going to do, okay guys, this is my banner. So I live in Toronto, Canada. If you want to if you want to know anything, you can just reach out to me. So config T, I will say do show IP. So here what I'm going to advertise everything the easy way. So router OSPF1 network 0.0.0.0 255.255.255.255 area 0. So what I'm doing, I'm advertising loopback 111 11 11 11. So with this one, I want to show you, if I go to PE1, let's enable OSPF on PE1. So let's do step by step on the left side, then we'll do on the right side. So here is different, guys. So if I type show run section OSPF, is running OSPF1. So now what I have to do, I have to go to router OSPF. I cannot type 1, so I'm going to type 2 VRF. The name of VRF is many ADB. So I'm going to say network. I'm going to say 12.12.12.0 0.0.0.255 area 0. So this is the network between router 3 and router 1. And also here what I want to do, I want to redistribute BGP 1 2 3 4 5 subnets. So because I want to so this the BGP redistribution is nothing but is coming from IPv4 BGP. So guys, now I want to do some BGP something. Let's go and see what is that one. Do show run section BGP. The problem right now, the CEP protocol is different routing protocol. My VPN V4 is BGP, so I had to do some kind of a redistribution. So here what I'm going to do, I'm going to do router BGP 1 2 3 4 5. Then I'm going to type address family IPv4 VRF. The name of the VRF is many ADB. So I'm still on BGP. Here I want to simply say redistribute OSPF2 match. Most of the time this is not a specific to MPLS, guys. So whenever you want to redistribute from OSPF to BGP, is best to type match internal external 1 external 2. If not, so right now I don't care what routes are on the CE1. It can be any route type. It will be get advertised to OSPF. So that means whenever your routing protocol is not BGP between CEPE, you must do redistribution between OSPF and BGP. So let's go through the command syntax for you guys to understand. Show run begin router. Okay, let's see what was done. Maybe you want to make a so under router OSPF to VRF many ADV, I'm redistributing BGP subnets, and I have a network command. This is my global routing, so that means this is the one I'm running to my MPLS cloud. As I said, it can be either ISIS or OSPF. So this is my BGP. I'm saying do not establish normal BGP. Then I'm saying this for, look at this one, these two AS numbers are same. So I'm doing something called MPIBGP, multi-protocol interior border gateway protocol. Then under address family VPN v4, whenever you do, I have to activate the neighbor. Then I'm sending my route target community. This is not required. If I go down, then because my routing protocol is not BGP for VRF CEP, I have to go to address family IPv4 VRF many ADV. Then I have to say, please bring the route from OSPF2 and send to my VPN v4 route. So that this way the routes are going to go to this one will go the route to BGP IPv4. Then route target export will take the route to VPN v4. So guys, right now we talked a lot. Let's see a couple of commands. Show IP OSPF neighbor. So Cisco, what you have to understand, show IP OSPF neighbor will display both normal IPv4 neighbor as well as VRF neighbor. So you don't see the differences actually. You are seeing both. If I type show IP route VRF many ADV OSPF, I'm learning this route. So let's see my VPN v4 routing right now. If I say show IP BGP VPN v4 all, so that means if everything is good, this both 1111, 11, 11, 11, 11, and also 12, 12, 12, that link has to be in my VPN v4. That means if my redistribution is good and route target export is good. Just see, it is already in the BGP table. If everything is good right now, this route should be appearing on my, so P1 don't have a clue, right? Even though, as I said in my diagram, the P1 and P2, they don't have a clue about whatever happening. So if I type show IP route, you don't see anything. You see only the core network. And also guys, I'm going to show you a very powerful command in Cisco. The command is show IP route VRF star. Basically what it do, it goes and check the global routing table as well as it will show you all the mini routing table. That means anything in the verse. So that means if it is not there, that means the routes are not there. But if I go to PE2, let's see this one guys. It's a very important thing. Right now I want to show you the diagram. The routes are coming here, routes are coming through special BGP. It should be in the VPN v4 table, but I didn't create this one. So let's see if the routes are in the VPN v4 table. So show IP BGP VPN v4 all summary. Oh, I'm receiving 3 routes. That's good sign. Here I'm seeing all the routes in it. Then let's see this one. Show IP route VRF many ADV. Just see all the routes are appearing into my VRF table, but other side is not done. Just see everything is 200, 200, 200. That means I'm learning route through an IBGP. So between PE1 to PE3, I have a MP IBGP. So multi-protocol interior border gateway protocol. So guys, it's time to do this side now. And if everything is working, we should be happy. So let's do this side. As I said, CE2 is easy config. There is nothing major. So let's do this side guys. Okay. So many advantage banner is coming. Then enable config T router BGP 22222. No auto summary, no synchronization, neighbor, I think 26.26.26.6, remote AS12345. Then I'm going to put a network command. Network commands are 2.2.2.2 mask 255.255.255.255, and also network 22.22.22.22 mask 255.255.255.255. Okay, this side is created right now. If I type show run normal BGP is a very basic BGP. I have a neighbor command, but there is no neighbors because I haven't configured other side. Show IP BGP summary. So there are a couple of ways to do show BGP IPv4 unicast summary. So this is a new way of doing actually. I can also type on this PE1 show BGP VPN v4 unicast or summary. So try to practice on both the commands. Show BGP. So first of all, I type show IP BGP. Now I'm typing show BGP VPN v4. So just see. So let's configure PE2, guys. So this is very important. So I'm going to configure now eBGP. Okay. So let's see the configuration. Show run section BGP. Okay. So what I'm going to do. So remember, whenever CEP protocol is BGP and VPN v4 is BGP, the main advantage, there is no redistribution. So simply I'm going to do router BGP 1, 2, 3, 4, 5. I'm going to say address family IPv4 VRF many ADV. Then I'm going to say neighbor 26.26.26.26.2 remote AS22222, and not only that, I must activate the neighbor. The command is neighbor activate. That's it, guys. So there is no redistribution on this one. So if I show here show run section BGP, let's make it big. Router BGP. So this is the way you configure. So you can make a snapshot and do it. So this one I did not create. This one is coming automatically. You must know when the BGP AS number is same. I'm doing VPN v4 peering. If the BGP AS number is different, it is a CEPE routing protocol, and this is the VRF name. So guys, let's see the VRF routing right now. Show IP route VRF many ADV. Just see, I have a couple of routes as 20. So 20 is my own local site, 2020. So I should be seeing 220. That's right, 20. This is 120 and this other 20. I'm seeing 200. 200 is coming from other side. And if I want to know if my local routes are in the VPN v4 table, I can say show BGP VPN v4 unicast all. So very good sign, guys. Here I'm seeing these are my coming from other side, these are my local routes. So technically speaking, CE2 should have a neighbor relationship right now. Let's see, show IP BGP summary. If I type show IP BGP, I should see the route. I'm seeing 111.11.11.11. So our goal, let's go back to the diagram. Our goal is nothing but 111 should be able to ping 222 or 2222. Same way 222 or this side has to talk to this side. That's our main goal. I think we achieved that goal, guys. If I go to this router, this is a OSPF speaking router. If I type show IP route OSPF, here I'm seeing 2s and 22s. If I type show IP route connected and say my connected route. So let's test, guys. Ping 2.2.2.2 source loopback 0 is pinging. So so guys, our MPLS is working. Before I finish in the lab, I will capture all the show runs. So if you want to pause and you can do something, you can just do it. So so what I'm going to do, guys, I can ping. So router 1, I'm going to telnet to router 2 all the way to see the success. So telnet 2.2.2.2. If I do this one, it will work. I'm on router 2. So let's go back now. From router 2, if I do that one, it will not work. The reason, I did not advertise this 2626 network in BGP. So that means router CE1 don't know. So the only way to do from here, I have to say telnet 1.1.1.1 source interface loopback 0. So this will work. So if I do normal telnet, it does not work. This will work. So guys, I have the basic connectivity between back and forth. So again, make a note of if you want, take a picture of the diagram or make a note of the diagram. Again, this is Juniper Cisco master instructor many advantage. I'm Pravin's friend. And guys, again, so let's go and analyze these 4 routers. They are the main router as well as this VRF configurations. Guys, this is very good lab. If you can do this lab on a GNS or WebIOU, any kind of a simulator from Cisco, that means you know MPLS, then you can just make your knowledge even more. So let's go to starting from PE1. I won't type show run and capture. So let's go page by page. This is VRF configuration. So I can see I have enabled VRF in this interface and loopbacks are /32. This is the IP. Then there are 2 OSPF. One is a VRF OSPF toward the customer. Other one is the main global table. As I said, the global can be any IGP. So this I'm showing you how to configure CEP routing. It's not CEP routing protocol. It's a VPN v4. Then to redistribute, I'm creating this one to redistribute OSPF to this way. Then we talked about this match. P1 is very simple. So before that one, I want to show you another command as a troubleshooting for CCIE or CCNP. Show run pipe include CEF, LDP, MPLS, inter. So this one I use very heavily. It tells you whether IPsec is enabled or not. It tells me like MPLS label protocol is LDP. It tells me the loopbacks. It tells me what interfaces I have enabled for MPLS, and then it shows me MPLS LDP route ID loopback 04. So it shows all the commands. Necessary commands is very vital in the troubleshooting section. So P1, I'm going to go page by page. So these are loopbacks. I have only OSPF one, that's it. There is no BGP, is part of the main global routing. It's a very simple configuration. Only thing is I enabled this one, also same thing, very simple configuration. Again, banner, enable, show run. Let's go to PE2. Again, this is very important. Again, the very important configurations in the MPLS is PE configuration. So provide the edge router, show run. So as per our definition, there are VRF, again route target, import expert, they are reversed. So I'm saying protocol is LDP. I have defined all the loopbacks. Again, I have one global OSPF. And also I have a VPN v4 BGP and also VRF also BGP. So that means, as I said, if these two numbers are same, that means I'm doing VPN v4 peering. If these two numbers are different in a different address family, I'm using CEP routing protocol also as a BGP. So that's it, guys. Hopefully you guys enjoyed this video. And going back to the diagram, very important diagram. When you do this lab, you will know end-to-end MPLS. Guys, I think I provided the core of MPLS. Again, theory you have to study, or you can just contact by different means. You can contact me. But apart from that, just understand the MPLS. And also, if you are familiar with this setup, you can do some complex routing. And also, there is a VRF to VRF. If, for example, you can have hundreds of customers connecting to PE router. For example, just say you have 100 VRF, that means 100 customers. You're going to have around 102 routing table. One is 100 VRF routing tables for different VRF, one VPN v4 routing table, and also one global routing table. So VRF is very important. If you go to Juniper, VRF is called routing instance. If you go to Alcatel, the VRF is called VPRN, that means virtual private routed network. So I might be putting some more videos on Juniper, Alcatel in the down the road, but again, hopefully you guys enjoyed the video. Thanks for watching this video. Good luck for your future studies. Thanks for watching this video. And again, this is Many Advantage, your Cisco Juniper Master Expert Instructor at